Ready. This is Digital Blackboard by Sachin Pinakmote. In this video, we are going to discuss the topic Laplace transform of sine wave. So we are having one question. Write the equation for following voltage waveform and obtain its Laplace transform. So we can see one voltage function is given and this waveform is nothing but sine waveform. It is having positive maximum value and then negative maximum value. So we have to write down its voltage equation. Now always remember one thing, for any sine wave we have to write down two equations. So the first equation is for the starting point of that waveform and the second equation is for ending point or finishing point of that waveform, whether that waveform is half wave or full wave. Here we are having full wave, positive half cycle and negative half cycle both are available, so this is full waveform. Sometime it may happen that you will be given only half waveform, so then only you can, then even you have to write down two equation, first for starting point and next for finishing point. So here the starting point is at instant 2 and finishing point is at instant 4. Now while writing down the equation of for a sine wave, we have to keep in mind that f of t is equal to Vm sine omega t, where Vm is the maximum value of that wave. So here maximum value is 10, it is clearly given here. And then after taking its Laplace transform, so always the Vm, that is maximum value, is constant, and then the Laplace transform of sine omega t is omega upon s square plus omega square. Now so the next thing which we must remember that in for this equation we have to replace the value of omega. So how to replace the value of this omega? So for that, use equation omega is equal to 2 pi f. Okay, now f is nothing but frequency and f is equal to 1 by t, where t is time period. So by putting the value of that omega instead of f, we can put 1 by t, and t, that is time period, can be easily find out for any waveform. So let's start with this problem. We will solve this. First of all, we will write down the equation of this voltage equation. So v of t will become equal to 10 sine omega t minus 2 u of t minus 2 minus 10 sine omega t minus 4 into u of t minus 4. Now how we got this equation? So what is 10? 10 is the maximum value. Then this is sine function omega t minus 2. Why we have written t minus 2? Because this for the starting point it has been delayed by 2. Okay, by 2. That's why t minus 2. And u of t minus 2, it is unit step function is always associated with any function. That's why u of t minus 2. And here from starting point the waveform is going to the positive half cycle. That's why the magnitude of, that is the sine of this 10, is 10 plus 10. Then we are going to write down the next equation at ending point at for the instant 4. But now it is a finishing point, but for finishing point the waveform is coming from negative half cycle. So as the waveform is coming from negative half cycle, we have to put minus 10. Okay, so the magnitude is minus 10 now. Again sine omega t minus 4. So why we have written t minus 4? Because the finishing point has been delayed by 4. So t minus 4 into u of t minus 4. So we have written the equation for the voltage waveform. So this is the first part is over for this problem. We obtain the voltage waveform equation. Next we have to obtain its Laplace transformation. Okay, so for obtaining its Laplace transformation, so taking Laplace transform of v of t, so for v of t the Laplace transformation is v of s, then 10 as it is, and for sine omega t we are having the Laplace omega upon s square plus omega square, and as it has been delayed by 2, that's why e to the power minus 2s. Okay, then minus 10 is again common. Then for sine the Laplace is omega upon a square plus omega square, and it is also delayed by 4, so e to the power minus 4s. So we got the Laplace transform of the equation. Okay, now we have to replace the value of omega. So how to replace the value of omega? So we will use the relation omega is equal to 2 pi f and f is equal to 1 by t, where t is the time period. So what is the time period for this waveform? So the waveform is starting from 2 and finishing at 4. So the time period, the time required to complete this waveform is 2 only. From 2 to 4 it is 2, or 4 minus 2 is 2. So t has been given, that is 2. So omega becomes 2 pi. Instead of f, we have written 1 by t, and t is equal to 2. So finally omega is equal to 2 pi by 2. So omega comes to be 2. So we have to replace omega by 2 here. So we will replace omega by 2. So wherever we are having omega, we will replace it by 2. So omega will become 2. Here we are having omega square. It means 2 square. So 2 square is 4. So omega square has to be replaced by 4. Omega has to be replaced by 2, and omega square has to be replaced by 4. So we got V of s here. Now if we again solve the equation, again simplify it, we can take 10 into 2 upon s square plus 4 common. So in the bracket we will be having e to the power minus 2s minus e to the power minus of 4s. So we got the final answer for this waveform given. So I hope you understood this problem very well, and the idea is clear. We can solve any problem of sine wave. So please like, share and subscribe Digital Blackboard. For any query you can contact Sachin Nagbhote at gmail.com. Thank you very much.